Start better.
Conduction,
Tester.
conduction, conduction
Tester.
tester using LED. Sometimes the current flowing through the circuit may be too weak and the filament of the bulb may not get sufficiently heated to make it glow. Then, instead of a torch bulb, an LED can be used in the circuit. LED glows even when a weak current flows in the circuit.
Fine. What have you understood from this is that always currents are not with intense. Sometimes they are very weak, sometimes they are very strong. If the currents are strong, then the bulb will start glowing. That is very apparent. But if the currents are weak, the bulb will not glow. That does not mean that the current is not flowing. Hope you understand. At that time, what is important? If we take LED, the LED can detect even the weakest of the current and it will start glowing. So generally what happens when the bulb does not glow? Simple, I'm the ordinary bulb. So we say there is no current. But there may be current. You understand? There may be current. But that current may be weak. And the bulb cannot glow because bulb needs high electricity, strong electricity. You understand? Whereas LED can detect the weakest of the current. So if the weak current is flowing, then if we have LED in the circuit, then LED can detect the weakest of the current and it will start glowing. Have you understood? Boys, have you understood? Hello?
Yes, ma'am.
Okay. So here you can see this is the circuit and the LED is fixed over here. If it is very faint, if the uh, electricity is too weak, then also the LED will glow. So this is how the LED looks. Can you see this, Vita? The red ones, these are the LEDs. These ones. These ones are the LEDs. This is another circuit with 9-volt battery with only one LED, any color you can see over here. Here we can have three uh, LEDs with same 9-volt battery. You understand? So this is how you can make your circuit. What are we going to see? Testing with a magnetic compass. Just now what we did? First we took up an electric bulb. Second we took LED. The third what we are going to take is a magnetic compass. Hope you are understanding what we are doing. Boys, did I answer at least? There is no response from your side.
Yes, ma'am.
Okay, start. Conductors tester using a magnetic compass.
If a magnetic compass is kept near a wire and current flows through the wire, the magnetic needle gets deflected. So we can use a magnetic compass instead of a torch bulb or LED in the circuit. The magnetic needle gets deflected even if a weak current flows in the circuit.
Same thing. It's only we are only concerned with weak currents now. One was LED, which could detect the weak current, and the next is the magnetic compass. Even that can detect the weakest of the current. So in the circuit, we are keeping a magnetic compass near the circuit or in the circuit, doesn't matter. And the current is flowing to the wire. What happens? The magnetic needle gets deflected. So instead of torch bulb or maybe LED, what we can use? Magnetic compass in the circuit. What it shows that if there's a flow of weakest of the current, then also the magnet detect it, can make out that the electricity is flowing. You understand? And the needle will start fluctuating. The needle will show the movement, it will show the deflection. This is how it looks. See, this is the circuit. You understand? This is the magnetic compass. You see this better? These are the needles. Can you see this needle? It will show the deflection like this or like this. Okay? Any problem regarding this slide? Boys,
And
we're going to work on electrical conductors and insulators. Yes.
conduction of electricity. Similar to many solids, some liquids also conduct electricity. Conductor substances which allow
Allow.
electricity to pass through them are called such as silver, gold, acidic solution, salt solution, etc. Insulator substances which do not allow electric current to pass through them are called insulators such as plastic, rubber, etc.
So what is conduction of electricity? Anything which conducts in electricity, this phenomena, the process of conducting electricity is known as conduction. We know solids conduct electricity, so solids are conductors of electricity. Same way, some liquids also conduct electricity. That means it allows the current to pass through. What is conductor? The substances which allows electricity to pass through them, they are called as conductors. I think all of you know that. Examples are silver, gold, some solution, like if you put a bit of HCl acid in water, that solution, the dilute solution of HCl becomes acidic solution and that can conduct electricity. Similarly, salt solution. You take the table salt, there is sodium chloride, you mix it with water, right? And that salt solution also can conduct electricity. Now we come to insulator. It's just the opposite. The substances which do not allow the electricity to pass through them, they are called as insulators. So, example, you got plastic, you have rubber. Remember, we generally use rubber slippers while we are ironing our clothes, isn't it? Isn't it? So that there should not be any sort of accident happening to us because we may be electrocuted. If at all there's some electricity passing and by chance we touch the metallic portion of the iron, either we get burnt or we get electrocuted. It maybe if there is some uh, connection or misconnection of wires, sparks may come out and we may get electrified. So all these actions not to happen, what we use insulator in the means of rubber slippers. You understand? So that we are not electrocuted. You got it? Because rubber is a insulator. Hope you understand what I'm saying. Boys,
Yes, ma'am.
yes?
Yes,
Now more about conductors and insulators. Please read. We'll come to know some more examples from this slide. Just start reading with a
Conductors and insulators. All, all substances do not allow electric current to pass through them. Base ability substances are divided into two categories: conductors and insulators. Substances that allow heat or electricity to flow through them readily readily are called conductor. For example, metal and some non-metal such as graphite are good conductors of electricity.
Fine.
Substance
That's it. So what new thing we understood, Moinuddin? Can you explain better? What new things we got in this slide regarding conductor? Can you tell me? We have divided substance into categories, conductors and insulators that we had done earlier. What extra you got in this? Can anyone tell? In the earlier slide, what we learned? Substances which allow electricity to pass, isn't it?
Substances that allow heat or electricity. We learned that
Exactly,
new.
exactly. This is what something extra you got in this slide. That is what I'm saying, Beta. In each, see, I may be taking one topic with different slides, but all the slides are giving you some or the other extra material, extra information. You understand? That's the reason that I'm taking so many slides for one
Yes, ma'am.
topic. Got my point? So what you extra you got over here, Beta? Heat.
Heat,
What extra you got? Moinuddin?
heat.
Heat, because you read it out, so I thought you will be the
Heat.
first one to figure it out that this is the
yes,
extra we have got over here. There's another thing which you can say.
yes,
Which is the other thing, beta?
yes, ma'am.
Which is the other thing extra?
Graphite, metal and non-metals.
Exactly. Very
White
good.
matter.
Very good. Very good. That is graphite. Non-metal is graphite. What we had talked about in the earlier slide, only metal, isn't it? And liquids. What we are talking about? Metals, salt solution, and acidic solution. Remember?
Yes, ma'am.
Yes. Now what we are talking about? Non-metals. We are talking about non-metals. Which is the exceptional cases of non-metals? It is graphite. You understand? So graphite is
Yes, ma'am.
also a good conductor of electricity. Thank you. Now let's do the insulator part, beta. Start. Begin, beta.
Substance, substance that do not allow
Substances.
Substances that do not allow the free flow of charges through them are called insulators. For example, dry wood, plastic, rubber, wool, and cotton are insulators.
So what extra information regarding insulators in this slide? Please read it out. Only
All the
extra information.
examples.
Yes. Most of the example. No, plastic rubber we know better.
Yes, dry wood,
Plastic rubber we
plastic,
know.
wool, and cotton.
Yes, ma'am.
The earlier side we had plastic and rubber. You agree? What extra we
Yes.
got? Dry wood, wool,
Wool,
cotton. You
cotton.
understand? Yeah. So these are
Yes,
the
ma'am.
extra information regarding insulators. This is what you have to gather from each and every slide. Okay? Now, what we talked about earlier? Conductor and insulator.
And
Now, what we are going to
insulator.
talk about? Good
Good
conductor
conductor
and
and bad
bad
conductor.
conductor. Yes. Please begin.
Ma'am, can I read?
Okay, no problem. Oh, no problem. Murugan, is it okay if Mohammed reads it? But Mohammed, I want to tell you one thing. If you really want to read, you have
Yes,
to be
ma'am.
sharp at 8 o'clock.
Okay, ma'am.
Promise me, beta, most of you, we wasted almost 15 minutes, beta. It's not good at all.
Ma'am, but I can't join because no one has added me in that.
Was it like that? Okay, I'll
Yes,
do the
ma'am, it
honors.
is waiting
So don't
that
worry
you
about
will
it.
join now,
From your
so I
side,
was late.
okay, okay, okay. So from your side, you be present at 8 o'clock. Okay? I will see to it that you are joined. Okay,
Yes,
beta?
ma'am.
Do your part at least. Right. Thank you. Okay,
Good
begin. Good
conductor
conductor and
and bad
bad conductor.
conductor. Substances which allow electric current to pass through them easily are called good conductors of electricity, such as silver, gold, aluminum, etc. Some substances allows electric current to pass through them, but in very little amount. Therefore, such substances called bad conductors of electricity, rather than being called an insulator. In fact, most of the substances allow electric current to pass through them under certain conditions. So instead of using terms conductors and insulators, good conductors and bad conductors are used.
What are they saying? That let's not use the terminology as insulators. Instead, we will use good conductor and bad conductor. Simple. What are the good conductors? It
Silver,
conducts
gold,
easily.
aluminum.
No, no, no. I'm not talking about it. I'm talking about definition better. We'll come to the examples later, but let's finish the definition first.
Okay, ma'am.
So it is conducting electricity, no doubt about it. So it is a conductor. We know that it is a conductor. But how? Easily. What word we will use? Easily, without
Easily.
any hurdles. Yes. So it is a good conductor. Example, just now you said silver, gold, aluminum, they are good conductor of electricity. Any problem?
No, ma'am.
Now we come to other conductors, other type of conductors. They are also passing, the electricity is passing through them, but very little. What I said? Very little. That means there are obstructions. It is not passing easily, it is passing with difficulty. Now, the electricity which is passing through difficulty in very little amount, they are called as bad conductors. We can talk it as insulator. So, what we take it as insulators that electricity do not pass through. It is not okay. Electricity passes through, but in maximum or in minimum. But electricity passes through. Is it clear now? That is what they
Yes,
want to convey. Because generally all the substances, rather most of the substances, they allow electricity to pass through in maximum or in minimum. So we will not call it as conductors and insulators. Instead, we will call it them as good
good
conductor
conductors
or
and bad
poor
conductors.
conductor or a bad or poor conductor. So instead of bad conductor also we can talk about as poor conductor. You agree all of you?
Yes, ma'am.
So something new again we understood from this slide better.
Yes, ma'am.
So because so far we were talking about only conductors and insulators. Now we will not talk about like that. We will be talking like
Good
good
conductors
conductor
and
and
bad conductor.
yes, Moinuddin, even you can comment better. Where did you go? Is
No,
he
ma'am,
there?
he is there. Yes,
He's
ma'am,
there?
there.
Okay.
Yes, ma'am.
He's not answering, so that's why I said. Okay, start.
Electrical conductors. Electrical conductors are materials that allow electric current to flow through. Examples: salt water, metals such as copper, aluminum, and non-metals like graphite, a form of carbon.
Okay. Now, electrical conductors obviously allow electric current or electricity to pass through. We have salt water, that is your table salt dissolved in water that can conduct electricity. Metals, example, copper, aluminum, and non-metals like graphite. So we know that. Now, what is graphite? It is a type of carbon. Now, look over here. This is copper. You see this orange color?
Yes, ma'am.
This is copper. This is silver. Silverwares. Your fork and your spoon
Spoon,
and
knife.
knife. Yeah, all these are made up of silver. Then we have aluminum vessels. See, can you see these aluminum vessels? These are the
Yes, ma'am.
wires. These are the wires. Okay, and here is the graphite. The lead that you have in your pencil. This one, can you see this? This one,
Yes, ma'am.
by which you write on the paper, that
Yes,
is
ma'am.
graphite. What it is, beta? Graphite. It is
Graphite.
a yeah, it is a type of carbon. It is allotropes of carbon. Because you know that Marble is a type of carbon. You agree? It's white colored. Diamond is a type of carbon. It's the
Yes, ma'am.
expensive of all. You know that? It's the expensive of all, expensive metal of all, diamond. And the third one is graphite, softest of all. You understood now?
Yes, ma'am.
There are three types of allotrope. These are called as allotropes, types of carbon. One is marble. You know the Taj Mahal is made up of marble, white colored.
Yes, ma'am.
Second is diamond, a type of carbon, and the third one is graphite, another third type of carbon. Do you understand?
Yes, ma'am.
Now we see electrical conductors of solids. How solids conduct the electricity we are going to see in the circuit. Please start.
Electrical conductivity of solids. Some solids are good conductors of electricity. Example: copper, steel, iron, aluminum, etc. Some solids are poor conductors of electricity. For example, wood, plastic, rubber, glass, etc.
Nothing new. I'm only showing you the circuit. Okay? We know
Yes,
about whatever you read it out just now. Are we aware of it, beta?
yes, ma'am.
We know about it, right? So what I want to show you how you can do it at home. So we'll make a circuit. Can we make a circuit like this? Yes, beta.
Mhm.
And instead of this thing, can you see this wood? We can
Yes,
use rubber, we can use plastic or iron nail
glass.
or paper clips or glass, whatever comes to you, whatever is not thrown in your house. You can take a leaf, you can take a green leaf, you can take a dry leaf, anything you can take.
Anything.
Yes, anything. And you fit it in between. Circuit will remain the same. If the bulb glows, that means it is a good conductor of electricity. If the bulb does not glow, it is bad conductor of electricity. Have you understood?
Yes, ma'am.
That's all. This is a activity that you can do at home. Okay? This is the
Yes, ma'am.
battery. This is the battery. This is a bulb, and these are the things that you are going to do the activity with, just to find out or categorize whether it is a good conductor or bad conductor of electricity. All of you understood better?
Yes, ma'am.
Now, conductors is done. Now we are going to talk about insulator, please, or the bad conductor.
Electrical insulators. In electrical insulators are materials that do not allow electric current to flow through. For examples, plastic, wood, rubber, glass.
Anything new?
No,
Okay. The only new is the figure. See the diagrams or the pictures that we are showing. This is rubber,
yes,
this is
yes,
wood, and these are plastics, right? So
yes,
these are the bad conductor of electricity. Now we are going to do certain activity to see the testing of conduction of electricity through liquid. So far what we did, metals, solid, isn't it? So far what we did, beta? We tested with the
yes,
solid. Now we are going to test the conductivity with the liquid.
liquid.
Start.
Liquids, which contains salt dissolved in them, conduct electricity. The conduction of electricity through a liquid can be tested using two electrodes and a bulb.
So what we want,
But
just a moment. In the circuit, what we want, liquid, which liquid it is? Containing salt, isn't it? The liquid will be having
yes,
salt. Then what else we want? Two electrodes
two electrodes and a bulb.
and a bulb. So these are the things that we require for the circuit. Next,
But the conduction of electricity through the liquids which are poor conductors cannot be tested. But conduction of electricity through such liquids can be tested using LED or magnetic compass needle.
so you understood now? Because we know the current which will flow through the water is not that strong as it flows through the solid. You agree?
Yes, ma'am.
Yes. So how to detect that feeble current? How to detect the weak current? What we will use, beta? What will use? LED. I had
LED.
taught you. or magnetic
or
compass needle.
magnetic compass needle.
We know that it can detect the weakest of the electricity. You may know that, isn't it? That's why we'll be
Yes,
using LED and magnetic compass needle instead of bulb. You understand? Yes? Yes, start.
yes, ma'am. For this, you need a compass needle, an empty matchbox, two electric cells, some wires, a plastic bottle cap, and the liquid which is to be tested. Keep the compass needle inside the empty tray of matchbox and wrap a couple of rubber bands around it. Connect the wires to the battery and insert two wires in the liquid which is kept in the plastic bottle cap. You will observe that when the current flows through the wire, there is deflection in the compass needle. This shows that the given liquid conducts electricity. In fact, magnetic compass needle can detect even feeble current.
Feeble.
LED can also feeble current. LED can also be used in place of compass needle.
You see the circuit over here? This is the compass needle. Can you see this?
Yes, ma'am.
This is the battery. Yes?
Yes,
And
ma'am.
these are the electrodes. And electrodes will have the bottle cap which has got the liquid. Yes or no?
Yes, ma'am.
And that shows the salt solution. The liquid, this is the salt solution. Isn't it?
Yes,
And
ma'am.
we will find whether when we put it on, whether the magnetic needle is deflecting or not. Then it shows that this salt solution can conduct electricity. You understand?
Yes, ma'am.
And we'll do only one para that is of salts, okay?
Yes, ma'am. Salts dissolved in water are responsible for conduction of electricity through water. Tap water, acid solutions, basic solutions, etc. are good conductors of electricity. Distilled water is poor conductor of electricity because no salt is present in distilled water.
Fine. So how salts can conduct electricity? Just imagine. If we are using the table salt or any type of salts and are dissolved in water, then yes, it can conduct electricity. Example, tap water. Now, tap water is coming with so many pipelines. You agree?
Yes, ma'am.
The pipes are made up of metals. You agree?
Yes, ma'am.
Certain metals, or certain what you call it, elements, it mixes with the drinking water, the potable water. Yes or no?
Yes, ma'am.
Yes. So we can find certain traces of elements or metals in the drinking water. So it can conduct electricity because there are salts in it. Acid solution, I told you, dissolve bit of hydrochloric acid or sulfuric acid in water and it can conduct electricity. Basic solution like sodium hydroxide, so it forms ions, it can conduct electricity. So they are good conductors. But remember, distilled water, this is the purest of water, devoid of any salt, cannot conduct electricity. You understand now? Now, where do we use distilled water better? Can anyone tell me? Where can we use distilled water? In
In
injections.
traveling.
Remember? In doctors they use injection in injections they use. Got it now?
Okay.
In small bottles you get, they take the syringe, puncture it, and take the water
Yes,
and
ma'am.
use it in those powder,
Yes,
and then they mix it, and then they inject you with that solution. Yes. So that is
yes, ma'am.
called distilled water. Now, distilled water is devoid of any salt, so it cannot conduct electricity. Okay, the same thing over here. So
Ma'am,
what we have
lecture
done,
is over.
okay, I'm sorry. So just remind me that we will be doing this tomorrow again. Okay, tomorrow we have a lecture.
Okay, ma'am.
Same thing, we will do it tomorrow.